Hello students, this is Professor Chalai, and in this video we're going to look at atoms, elements, isotopes, and ions. Now hopefully you've read on the various experiments that have been performed over the decades and hundreds of years that have made it so that we could understand exactly what an atom, how an atom is made up. And I'm not going to go over those experiments in detail, I'm just going to summarize some of their results. But as of today, sort of what we know about the structure of an atom is that most of the atom's mass and all of its positive charge are contained in a small core, which we'll call the nucleus. So all the positive charges and almost all of the mass are in that core. And so what that means is most of the atom, the volume of the atom, is actually empty space, through which tiny negatively charged, what we're going to call electrons, move about. And finally, for atoms that are neutrally charged, there are as many positive charges as there are negative electrons. There are as many protons in the nucleus as there are electrons. So a simple representation of an atom, and this is again just a cartoon because we really can't see an atom using optical methods. Let me change that to say that we can't see the structure of an atom the same way we can magnify the structure of a cell and see it through a microscope, for example. We can only infer its structures indirectly through various experiments. So if we were to draw maybe a representation of, let's say, a helium atom that has two protons, so let's draw a little two protons. Helium atoms typically have two neutrons as well. And they'll have two electrons. So this is the nucleus. So let's protons, neutrons. Together they make up, let's use purple, the nucleus of the atom. And around the protons and neutrons are often the electrons, and I'll just represent it this way. Exactly where they are and how they move we'll learn about in a later chapter. That's determined by quantum mechanics, but we'll call these electrons. Now, to simplify writing protons, neutrons, and electrons over and over again, I'll represent electrons by just an E with a minus charge because electrons have a negative charge. Protons, we're going to represent by P plus. And neutrons, we're going to represent with just an N because they have zero charge. So that is, in a nutshell, a simplified version of the structure of an atom. Now, all of the mass of the atom are in this nucleus, pretty much all of the mass. So they're in the protons and the neutrons, whereas the electrons have very, very little mass. Okay, so let's look at some definitions. First, let's look at the atomic number. The atomic number is simply the number of protons. So the atomic number determines what element you're looking at. So all atoms of oxygen, the element oxygen, will have 8 protons. The number of neutrons could vary, but the number of protons is the atomic number that determines what the element is. The mass number is the number of protons plus the number of neutrons. This is the mass number. And because the protons and neutrons pretty much have all of the mass of the atom, it's just the sum of the number of protons times the plus the number of neutrons. Okay. The atomic charge is basic. So all atoms pretty much are electrically neutral, but the atomic charge could just be calculated by the number of protons minus the number of electrons. And when you have an atom with a charge, we call that an ion, where the number of protons is not equal to the number of electrons. there is an overall charge. All right, so we looked at the atomic number, that's the number of protons, and we looked at the mass number, which is the sum of the protons plus the sum number of neutrons. Isotopes have the same number of protons, meaning they're the same element, right? The element is the number of protons is the atomic number, which determines the element, but they have different number of neutrons, meaning they have different mass numbers. Same number of protons, different number of neutrons. Whereas ions have different number of protons and electrons. All right, let's make sure we remember those. So isotopes, same protons, different number of neutrons. All right, let's go back to this idea of an ion. We said they have different number of protons and electrons, which means that the charge does not quite balance out. So a cation means that the number of protons is greater than the number of electrons. Or to put it in another way, the overall charge is positive. And vice versa, for an anion, the number of protons is less than the number of electrons, or the overall charge is negative. Right? The way I remember this is there's a T in cation, which is kind of like a plus sign, so cations are positive. All right, so this brings us just to the end of the this very short section on looking at the differences between elements, isotopes, ions, and atoms, and the structure of atoms. I will see you in the next video. Bye.